Bismillahir Rahmanir Rahim. We spoke about the binomial distribution in the last part, and we said that an probability experiment is defined as binomial distribution if four conditions are satisfied. Number of trials is fixed, and the probability of success is fixed, and if every trial is independent of the other, plus one thing that the outcomes must be classified or just put into outcomes. Either two outcomes or can be classified as outcomes. And we said that the probability of getting Px equal to n factorial. So remind, this is P of x. Probability of getting x success is given by the formula B of x equal to n factorial divided by n minus x factorial times x factorial multiplied by p to power x times q to power x, where n is the number of the trials and p is the probability of success, q is the probability of failure. Now let's have this equation to apply this formula. Last time, we gave some examples about the binomial distribution, and we are continuing this one. In this example, a student takes of 10 question multiple choice exam with 5 choices for each question, and we need to find the probability of guessing at least 3 questions. First of all, let's see, is this a binomial distribution or not? We have n equal to 10. This is fixed number of trials. And the outcomes, since this is multiple choice question, we have A, B, C, D, and E. 5 choices. One of them is true, the others are not. So suppose that B is the correct one. So all the others will be false. So the outcomes will be either true or false, which means that this can be put as 2 outcomes. One is correct, the others are incorrect. So it is true or false outcome, which means that this is, we can say this is binomial distribution. And in each case, we have only one true, and B in this case is 1 out of 5 is correct, which is 0.2. This means the same for all the questions. In each question, we have only one correct answer. So the probability of getting the correct one is 1 out of 5, which is 0.2. So Q will be 1 minus 0.2, that will be 0.8. Now we have at least 3x. So I need to find P of x greater than or equal to 3. It means x 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10. So this means I need to find B of 3 plus B of 4 plus B of 5 plus B of 6 plus B up to B of 10. This will take time if we do it in this way. So we can apply the complement rule. Complement rule is 1 minus B of 0 plus B of 1 plus B of 2. this will be easier. I can just compute 3 properties and subtract from 1. So this is 1 minus p of 0, p of 1, and p of 2. P of 0 is equal to 10 factorial divided by 10 minus 0 multiplied by 0 factorial multiplied by b, which is 0.2 to power 0 times q, which is 0.8 to power 10. This is equal to, this one will cancel this one. I mean, 10 minus 0 will be 10 factorial. 0 factorial is equal to 1. 0.2 to power 0, this is equal to 1. So the answer will be 0.8 to power 10. This is P of 0. P of 1 will be 10 factorial divided by 10 minus 1 is 9 factorial times 1 factorial times 0.2 to power 1, x equal to 1, and times 0.8 to power 9. That will be 2 multiplied by 0.8 to power 9. This can be using the calculator to power 9. Next one, I need to find P of 2. I don't have enough space for this one. It is 10 factorial divided by 8 factorial multiplied by 2 factorial times 0.2 to power x times 0.8 to power 8. Using the calculator for this one, I will have 18 divided by 2 is 9 multiplied by 0.2 or 0.04. So these are the properties for 0, for 1, and for 2. So the property of getting at least 3, I can write it here as 1 minus, write it down, we take this out. So b of x greater than 3 is equal to 1 minus 0.8 to power 10 plus 2 multiplied by 0.8 to power 9 plus 9 multiplied by 0.2 to power 2 times 0.8 to power 8. This is the property of getting at least 3 or x greater than 3. But we need just to use the calculator to find the final answer for this one. Plus will be plus multiplied by 0.2 to power 4 . to the power 8. So the answer will be, in this case, 0.563. So this is how to find the probability for this one. We have this information, and we just apply the formula to find P of x greater than or equal to 3. Let's have another example. Compute the probability of x success using the table B. Sometimes, or there is a already pre-made table for the binomial probability. In this example, we are going to use the table to find the probabilities. Compute the probability of x success using the table B. There is a table in some textbook or in the index named table B. And I need to compute the probability of x success. This is the table that already calculated using some software and different values for n, x, and different values of p. The first one, I need to find the probability of n equal to 5. I have 5 times p. The probability of success is 0.8 and x equal to 3. To use the table, we have the first column give me the value of n. So I need to look at n equal to 5. But we are given that n equal to 5. P equal to 0.8. This will be in the horizontal one. This is 0.8. This is for P. And x equal to 3. X equal to 3 in this area from 0 to 5 for this n. This is x equal to 3. So if we move horizontally, and for 0.8, the intersection will be the probability for the binomial distribution. This is the idea of using the table B. This is already calculated for different values of n and p. And using the table, it will be direct. So P of x in this case equal to this one. P of 3 equal to, from the table, I missed that one. This 0.205 equal to 0.205. Now, if n equal to 7, we'll go for n equal to 7. This is n equal to 7. And x equal to 0 and p equal to 0.05. Okay. This is x equal to 0. And 0.05, it is the second one. It is this one. 0.698. So the answer is 0.698. So P of 0 for this one, 0.698. We can apply the formula and to give me the same answer, but this is already calculated in the table, so it will be easier and faster to find the probability. Next one, n equal to 6 and p equal to 0.5, x equal to 5. We'll go for n equal to 6 this time. N equal to 6, this is n equal to 6, and x equal to 5. This is x equal to 5. So we are in this row. And p equal to 0.5. 0.5, this one, will go down. So it is 0.5. 0.094. So the answer for this one x equal to 5, I wrote 0.094. Last one, n equal to 4, p equal to 0.63, and x equal to 3. N equal to 4, this is n equal to 4, and x equal to 3. This is x equal to 3. And b equal to 0.63. 0.63, we don't have it there. We have because only 0.6. So 0.63 is close to 0.6 or 60. So I'm going to choose the one that will be more approximate. That will be 0.346. This is the closest one to the 0.63 for B. So the value in this case, or the probability will be approximated equal to 0.346. So this is the probability. As I mentioned, this can be calculated using the formula b of x equal to n factorial divided by n minus x factorial times x factorial times p to power x multiplied by p to power n minus x. And we will get the same answer, which is given in this table. So this is the idea of how to use the table to find the value of the binomial distribution. We have different type of tables, one for the binomial distribution, one for the continuous or normal distribution that will be discussed later. This is the idea of how to use the table to find the binomial or the properties of binomial distribution. Now the next point is to find the mean, variance, and the standard deviation for the binomial distribution. Mean is given by n multiplied by p, variance sigma square equal to n times p times q. Standard deviation is just the square root of the variance. Direct application for this one. Let's find the mean, variance, and standard deviation for the binomial distribution. N equal to 1000, b equal to 0.1. So the mean equal to n multiplied by b. That is 1000 multiplied by 0.1, which is equal to 100. For the variance, sigma square, which is n times b times q, it is q times the mean, or I can say just 1000 multiplied by 0.1 times q. From this one, q is 1 minus 0.1, which is equal to 0.99. 0.99. That will be, this is 1000. Times 0.1 is 100, times 0.99 will be 99. Now the standard deviation sigma equal to square root of 99. Square root of 99, which is equal to 9.95. Next one, let's find the mean. Again, it is n multiplied by b. That is 500 multiplied by 0.25, which is equal to 125. For the variance, sigma square, multiply the mean by q. This one Q equal to 0.75. So it is, because this will be, it is N multiplied by B, that is the mean times the Q. So it is 125 multiplied by 0.75. That is 93.75. And the variance on the standard deviation, sigma equal to equal to 9.68. That will be 9.68. Next one, n equal to 36, b equal to 1 over 6. So the mean equal to n times b, that will be 36 times 1 over 6 equal to 6. From this one, b equal to 5 over 6. So the variance sigma square equal to 6 times 5 over 6 equal to 5. And the standard deviation sigma equal to will be square root of 5. And square root of 5 equal to 2 point something. Square root of 5 equal to 2.23 or 24. So this is the idea of how to find the mean, variance, and the standard deviation for binomial distribution. It is n multiplied by p, the probability of the sexes, and multiply that by q will give you the variance. Taking the square root, we will get the standard deviation. So this is the idea of the binomial distribution. We can apply the formula to find the probability, or I can use the table to find the values of binomial distribution. Mean, standard deviation, and variance also can be easily found by the formula.